On today's James on IT video, we're going to talk about VLANs, how they work, and the ways that you can use them, even on your own networks. So let's get into it. So VLANs are an integral part of any network topology. What VLANs allow you to do is both segment and separate your networks. Originally, VLANs were built not for a security perspective, but actually just to break up network traffic and to remove broadcast domains. What that means is if you have a standard regular switch or a hub, you can have a lot of traffic getting broadcasted here and there that the computers are going to see. Well, what happened is what's called a broadcast storm, where all the computers, because back in the day we had hubs which repeated everything. They were basically just multi-port network repeaters. They would throw that traffic out to every single endpoint, and it'd be hard for the computers to know, okay, which traffic do I want to listen to? And it would congest the network and make things run a lot slower. Well, that's when they introduced switches, which allows you a more direct communication between two computers. And then later on, now we have VLANs. And VLANs are a standard technology used in pretty much every single business, except for maybe even the smallest. But a lot of the smallest ones are even doing VLANs now too, because they're so useful. So how do VLANs work? Well, essentially, a VLAN allows us to separate network traffic. And typically the way VLANs are leveraged is you have a subnet, and that's a VLAN. And each subnet gets its own VLAN. Now there's other ways of doing it, but 99% of the time I've ever ran into it, it's always a VLAN equals a subnet, which that makes it easy. So that way you can separate that traffic and keep them all on the same network segment. But the nice part about this is switch manufacturers and network companies started making it so we could set up ACLs to separate that traffic. That way, one network cannot talk to another network, but yet those networks can still get out to the internet, or they can even get it so isolated down, they can only talk to specific machines on the same network between VLANs. So let's look at a diagram I've got here that'll help show what a VLAN looks like. Now, this obviously is a diagram. From the physical perspective, you're just going to have a switch and it has a whole bunch of ports. So externally, there's nothing there. But from the software side, that's where all of this is driven. So here we see we can have multiple computers connected to different switches and yet be part of the same VLAN. And to try and think of this, the separation of duties, it doesn't matter if they're in different buildings. It doesn't matter. You can have them actually even on other parts of the planet. You can VLAN them together if you wanted to. Larger corporations do that because they'll use a layer 2 across their WAN links to make that happen. And it allows them, for example, if we have an accounting VLAN like we show here, we could put all of accounting servers in here and isolate that so the engineering or marketing can't access that data. And that's all done again via ACLs. We can isolate those off. Same thing with like a guest network. Let's say you want to have a guest network where the public comes into your retail place or store or office or whatever. You want to set up a guest network so that they can have Wi-Fi and be able to access the internet, but you want to segregate that in a way where they can't talk to anything at all internally. That is easy to do via a VLAN and the proper ACL, because you basically create the VLAN, say you can't talk to any other VLAN except go up through the router. Now the way the switches communicate to each other and transfer this, let me show you this. It's called a trunk. The standard protocol used is 802.1q. That is a network standard. You can look it up. There's lots of great info. I'm going to link a great article on Wikipedia for you if you want to dig into 802.1q more. But essentially it allows us to isolate each of these networks. As you can see, they're separated by colors. But between the switches, because they have to be able to communicate to each other, it can send that traffic between the switches. That way, this computer on VLAN 20 and this computer on VLAN 20 can talk to each other. And that's how VLANs are isolated out. They actually use a number. That's all it is. And from a network side, let's go over this Wikipedia article so you can see. This frame here that we're pulling up, it shows the 802.1q header. Essentially, the switches inject this into the packet and say, okay, for these 4 bits here, we're saying exactly what we want this traffic to be able to go to. So what happens is on the back end, the software inside the switches and the routers, they look at this 802.1q header, and there are also proprietary VLANs, but pretty much everybody settled on 802.1q now. But they look at that header and they say, okay, this traffic is part of VLAN 10 or VLAN 1000 or VLAN 100, whatever it is, and says, okay, because it's in there, you can only talk to these other networks based off of my ACL table. In other words, what my admin says you're allowed to talk to. And that's really all VLANs do, is they allow you to separate a network, segment that out more, and then be able to isolate those using access control lists. So what does that look like on an actual switch? So here we're going to look at a VLAN setup. This is my own personal network in my home, and as you can see, I'm running Ubiquiti. Ubiquiti is nice because the price is right and it works really, really well. Let's go down here to the settings menu, and you can see here I've got two different Wi-Fi networks. These two different Wi-Fi networks, you'll see I've got some clients on this one but none on this one. Well, that's because this is my guest network. So this is my public network. So if someone comes over to my house and wants to get on the internet, then I can isolate them off. I also do things like isolate my TVs to this and other network devices that may pose a security risk to my own internal equipment. And that reason for that is a lot of those like TVs and stuff are very, very vulnerable to attacks. We'll probably talk about that in another video, but this just shows on my Wi-Fi, these VLANs apply both to wired and wireless connection. Now let's take a look at my VLAN setup. So as you can see, I've got two separate networks. I've got a default, which is VLAN 1, and guest, which is VLAN 2. This is how I separate my networks out. Now, by default, manufacturers always use VLAN 1, which honestly, that's not a good thing. If you're running this in a business or you want better security, never use VLAN 1. Now, the reason I left this here is I'm not really concerned about it in my own home because I don't have a whole lot of people coming and going, obviously, out of my own home. But in a business setting, you definitely want to change this because there's a lot of vulnerabilities that go into VLAN tag 1. It's best to change this to like 10, 100, 96, 12, whatever you want to use. And sometimes if you have like a few subnets, I've seen where VLAN ID numbers they'll start at like 10 or they'll start at 100. I've seen them they'll follow the third octet because their network subnets are all /24s. So like, let's say they're using 192.168.1.0/24. Well, instead of them making that .1, they'll make it like .10, and then 2 is .12, or they'll use .11. I've seen that too. There's something to that effect where it makes it easy mentally to know which VLAN just by looking at the sub, then you don't have to look it up as much. But both of these networks are tied back into my Wi-Fi here that I was just showing, where this is my default that I have all my network devices on, and then the other one is my guest, and that segmentation goes into here. The nice part about it is I've got a VLAN viewer. So this VLAN viewer, it shows where my VLAN tags are on my different devices. So here on my firewall, it's showing that I've got all VLANs going through my firewall. If I look at my main switch, it also shows I've got all my VLANs going through every single port. And the reason I do this is then I can plug anything in anywhere, and it's essentially basically a trunk port. And then I use my other devices to actually separate those VLAN tags to allow me to assign which one goes where. Now I can always change this. I can go in here and change a single port and switch it over to a separate port or isolate only certain tags get in. But you don't typically have to do that unless you just want to be honest, because what that does is it allows you to basically hard code what networks that device can talk to. There's nothing wrong with that. I do that all the time. I'm just not doing it here in my home, just as an example. And I've also got an aggregate switch. This is a 10 gig backplane that I have that connects my devices. I'm going to be adding some more in. So as you can see, VLANs are not that complicated. They're easy to set up, they're easy to maintain, especially if you use devices like Ubiquiti. Every device manufacturer has a different way of implementing or managing them through their interface, but it all works the same. So once you understand how VLANs work, it works universally. So if you have a device, by all means, leverage those VLANs, play with them, see how they work. Make your own internal network and make a guest network. That's the simplest type of VLAN creation that you can do. I'm actually building out my network right now. That's why mine is so basic. I literally got this up a little bit before this video, but I plan on doing some more segregation. We may go into that in a future video as I get my home lab going and things, but allow me to have like a backplane VLAN, to have a IoT VLAN where I'll put things like my TVs and stuff, because I want to keep the guests isolated from those as well. We can do device isolation with ACLs and things. It's pretty neat what all Ubiquiti allows you to do. Even though they're not the most advanced of system, they're quite versatile, especially for their price. So I'm not trying to put in a Bing for Ubiquiti, that's what I'm using, so that's what I'm talking about. So I hope you enjoyed today's video, and we look forward to seeing you in our next one.